Hey, welcome back, everybody. We're going to go ahead and introduce our next speaker, who is Shaun McCullough. He is the author of our brand new SEC 541 Cloud Security Monitoring class, and also an instructor of the SEC 545 Cloud Security Architecture and Operations class. So with that, Shaun, I'm gonna hand it over to you to get going here on threat hunting in AWS.
Thank you so much, Frank. I appreciate it. I'm excited to be here. Actually, some great talks. That last one, I love getting these roadmaps of, this is how you go towards maturity. At one point, I was running an IT infrastructure group, and I brought in these giant charts of these. This is the idle framework we should be going to, and everyone's like, oh. But it gives you this great roadmap and say, all right, I see where we need to go to. What are the steps we got to get there? So I loved it. I learned a lot from that. Thank you. So I wanted to talk about threat hunting in AWS, trying to take a look at specifically what are the kinds of attacks that might be different in the cloud environment than maybe attacks we would see in our on-prem environment, and really to look at some of the data creation services that AWS has, which have been mentioned, in some previous talks. So they're not new to you, but this is the places you go to extract log data, and I'm going to have to do something with that log data. And threat hunting is really a lot of that log data. So that is today's talk. So first of all, we got to do what is threat hunting. So let me make sure I can change slides here. There we go. Okay. So of course, what is threat hunting? We got to kind of distinguish it. Threat hunting, official definition would be proactive evaluation of the infrastructure. And that's really kind of like going out and figuring out what are attacks that might be happening in my environment that I can't readily see through my automated security services. So if I've got some malware detection system running on my host, and it says, oh, someone has downloaded this piece of malware and I've deleted it. Awesome. That's great stuff to track. I don't really consider that as much threat hunting because we've automated that. So threat hunting is more of proactively figuring out, hey, what are we vulnerable to? What are the kinds of attacks that I should be looking at? Can I detect that it's happening? And then going out and figuring out if that is happening. It's a lot of spending your time in logs, and that's kind of the good and the bad of threat hunting. I've talked to organizations where they'll have a couple people that's like their threat hunting team, and they're just given like a ton of logs, right? And it's just there's just a amount of it. And what do I do with these kind of logs? The good thing is that in AWS and other cloud providers, there's a lot of data that can be extracted from the environment, and it can probably be extracted in easier ways than maybe you're on-prem, where you have like 6 or 7 different kinds of services and software and hardware that's running and different ways of gathering data from it. In AWS, if you're living inside the environment, you have an easy API access to all your data. It's just kind of figuring out what is the data I need to grab first and how to make use of it. So a lot of logs that you might be dealing with. And so I want to talk a little bit about what is the threat and what are some logs that you might use to go and look at that threat. First part of threat hunting is figuring out in that proactive evaluation, I got to know what I'm looking for. And it's got to be it's a threat-driven kind of mindset. So you can have folks do auditing that are compliance-driven, and that's great. And have to do it for some organizations, but it's great to do that. Threat-driven is more like, hey, what could the bad person be doing in my environment? What could the attacker be doing? What does it look like? Am I vulnerable to it? How vulnerable to it am I to it? It's really kind of taking on the mindset of this is what the attack may look like. And so in order to do that, we have to have some information about what are the threats out there. You probably have a threat feed that has APIs, domains, and hashes, and that's great. And those are great things to make use of. Atomic indicators are like that are easy to detect relatively. Nothing's really easy, but it's easier to detect with those services. And you kind of can say, all right, this is bad. I'm blocking it. That's great. When we start getting into threat hunting, we're starting to look more at behaviors, or this is something that is normally done, but an attacker can make use of it. So what does that look like? If it's something that I can normally do, what can the attacker do with it? And so we got to start looking at all these threats out there. It's a lot of digging logs. So we have to figure out what is the nature of the threat, how is the attacker going to use it, by whom. Maybe not so much is the attacker, I don't know, Fluffy Bunny or APT, whatever. That may not be as interesting, but if you got to know, hey, I'm in the, I don't know, healthcare industry, what are the kinds of attacks that are being seen in the healthcare industry, right? I'm in the financial businesses, or I'm a mom and pop shop, and your threats might be a little different. And so you can kind of focus on the threats that are more important to your organization. You also want to look at what the vulnerability itself is. If there's a threat against my web servers, all right, let's spend some time looking at our web servers. What would the threat look like? Do I have the ability to extract the data to tell me the attack is happening? How do I get the data if I don't have it? And then I really believe that in threat hunting, the threat hunter should not just be looking at logs, seeing something weird, telling the SOC. And I've seen organizations where that's happening, and there's only so limited success from those threat hunters. What we really want the threat hunters to be able to do is understand this is the threat, this is how it works, and I can easily detect it, or it's difficult for me to detect it. And maybe it's really easy for the attack to be perpetrated. I've got information I can be feeding to my architecture team to say, hey, look, if you gave me the logs this way, I can detect these threats a lot better. Or if you install this service, we would block or mitigate or detour these attacks. And so the threat hunters, using this cyber threat intelligence information, can really drive a lot of discussion about how to fix the infrastructure. All right, so let me show you just a couple places that I like to use as examples for threat intel. This is beyond the IPs, domains, and hashes, right? So this is kind of like the behaviors. The first one I always go to is MITRE ATT&CK. That's probably just because I've been using it since its inception. I love MITRE ATT&CK. I love MITRE ATT&CK because it gives me a way of categorizing threats, difficult threats, that I can have a conversation with my other teams. So I can say, hey, look, go and take a look at this attack technique, give it a number, T1105, whatever it is, and they can go and look at it and go, okay, we're on the same page. Whereas before, it was kind of like, let me give you a big description of what I'm interested in, and then people have to kind of figure it out. I'm going to actually test the pen, if you don't mind. I should have told you ahead of time I was going to do this, but I'm going to make sure the pen works on this. So let me show you how the MITRE ATT&CK works, just from the way I kind of visualize it. This top row right here is the tactics, or how I would describe it is the intention of the threat actor. So the threat actor wants initial access, or they want persistence, or credential access, or discovery. And then down the list in the columns, or down the row in the columns, is specific techniques. And you can click on those and you can get a detailed description of how would they do that. So one of these is cloud service dashboard or cloud service discovery. So you can click into that and you can see details of what is the attack and how does it work. So I do like MITRE ATT&CK. It's growing. I'm showing you their matrix specifically for cloud. They have them for just specifically AWS and GCP, Azure, and then of course, Mac, Linux, Enterprise. This is a great place. If you come up with new techniques or you just see them, you could submit requests for adding to their documentation. So it's great. I love it. All right. But that's not the only thing. In our cloud environments, you're probably got a lot of web servers. Maybe it's web servers like humans are going to use inside of a browser to go browse something, or you might be moving a lot of your infrastructure from monolithic applications into microservices, which could be a lot of web servers. So OWASP is an organization that comes out with this top 10 list of web techniques that you should be looking at. Web threat techniques or web actor techniques. These are the things the attacker can use against a web server, and they've prioritized the list. But Each one of these you click into, there's a wealth of information of what is the attack technique? How would you mitigate it? Here are specific examples of it happening in the wild. And here's how you can test in your own environment. So, if there's an attack against a web server, they'll have ways to describe the attacks. Since a lot of our infrastructure in the cloud, especially a lot of our vulnerable infrastructure, can be web applications, I always say this is a great second one to go take a look at. The third one is the CIS critical controls. It's probably not really cyber threat intel because it's not describing an attack. It's on the control side of things. But I really think it's a fantastic way of figuring out, okay, is my environment locked down? If I have these controls in place, am I able to detect things easily or maybe mitigate things? The other great thing is that in Amazon, there's a lot of services like Config and Security Hub that are mapping their results to the CIS critical control. So I'm a big fan of CIS critical controls. I'm a big fan of their benchmarks for EC2s and AMIs, those kind of things. So definitely another place to go and look and learn and understand what are the threats and the protections against them. So big fan of those. All right. So what I'm going to do is take a look at individual attacks, and it's just a sampling of them. And one of the tools that you could use in AWS to go and detect those attacks. And now for every one of these things, there's a long conversation of how do you analyze it? How do you detect it? All those kind of things. But I want to really kind of highlight, this is where that data lives. So the first attack is from the MITRE ATT&CK techniques. I didn't mention it before. The word attack is adversary tactics, techniques, and common knowledge. So it's an acronym that makes up a word, which MITRE does that a lot. They spend a lot of time making those acronyms into words. But there's one particular MITRE ATT&CK technique in the cloud environment or in the cloud matrix that's called cloud service discovery. This is the idea that, hey, if someone were to gain access to your environment, let's say they're sitting on one of your EC2s, an attacker has gained access to that EC2 because of a misconfiguration or the web server has a vulnerability, whatever it is, it's going to happen. Likely. So it's hard to say from security teams that, hey, this is going to happen to you, but it will happen to you. Once they gain access to their environment or they get your keys or they get some kind of security credentials, the first thing you're probably going to do is start figuring out what's running in the environment. What do I have access to? And so they'll start looking at things like, what are the S3 buckets? What are the EC2s that are running? What are the IAM roles and the users and like all of this stuff. And this is all about discovering the service itself. It's really simple. As a developer, you're probably doing this all the time, or if a security team, you might be running these commands, but the attacker is going to be running the same commands too. So AWS S3LS, I would give me a list of all my S3 buckets. That would be as an attacker, that's the first thing I would do. All of those interactions are interacting with Amazon's control backplane, which means they're API calls. And those API calls are being tracked in AWS CloudTrail. The AWS CloudTrail service allows you by default to retrieve most API calls. Now, the last time I looked, these are kind of a list of some of the API calls that are not fully provided in the CloudTrail. That actually changes quite often, so there might be a little behind on this. But this is August, I think, is when I went and grabbed this. But things like Trusted Advisor, maybe workspaces, artifacts, you may not get all the API calls. But for the majority of your environment, anything that you're doing about manipulating, changing, creating, or listing EC2s, S3 buckets, it's all going to be tracked in CloudTrail. CloudTrail by default stores that data for 90 days, but you can specify, hey, I want specific types of logs to be stored for longer. You can send them to an S3 bucket, or you can send them to CloudWatch, which I'll show you in a minute. But this API information is really describing when the query happened, by whom, was it successful, who returned it, but not the data itself. You're not actually getting the list of the S3 buckets in this call, but you are seeing that the call's been made. Data is being stored in JSON format, so it's pretty easy for an application to go and extract that information and analyze it and do something with it. All right. So the CloudTrail screen is really going to give you some good information in the GUI. Like if you go and click on CloudTrail and you're taking a look at it, it's going to give you some good information about when it happened, what was the event name, so this case listing the buckets, the source IP address that it happened. So if it's happening outside of your AWS environment, that'd be one thing. If it's happening inside of your AWS environment, another one. I also like to look at things like the error code, access denied. If you are working in an environment that you have high levels of automation, you have infrastructures, code, and all these really great fancy terms, your coding systems, assuming that they're working as expected, they're not usually going to go and query S3 buckets. And they're certainly not going to query S3 buckets on a system that's not denied. Like it's kind of been built so you don't do that. And so, but if I were an attacker and I were to gain access to a web server and I were to start to look around, I might get some access denies because my IAM roles are not set up properly. So you can start kind of looking at this CloudTrail. You can say, hey, there's an attempted query. It failed, maybe it succeeded. And who made that query? Was it the developer machine? Was it the administrator working on a jump box? Or was it my web server? And it's never really done that before. So that's your CloudTrail data. Your CloudTrail data is giving you, it's really a ton of information about the environment, interactions with the environment. But you're also going to want to kind of look at maybe things that are happening with applications themselves. If you're running a web server inside of your environment, there may be a network attack against that web server, maybe a brute force attack, such as an SSH brute force attack, or an FTP brute force attack. I know we're running FTP servers in our environments, right? I mean, as much as we probably don't want to, we are. And a remote desktop, there's other kinds of protocols that might be open to the internet that an attacker might try to attack and gain access. From the attacker perspective, this doesn't really look different than an on-prem. I see there's a port 22 open, I'm going to try and attack it. But we have different ways of collecting network traffic. In our on-prem environment, we've probably got a big piece of equipment sitting on that gateway that's gathering up all of our packets, and I'm analyzing them in real time with some service, but I may not have that in AWS. AWS does have a service called VPC Flow Logs, and VPC Flow Logs gives you the ability to look at packets, at least the metadata of the packets, not the full packet, but the metadata of the packet going across the network interfaces. And you have some ability to say whether I want all my network interfaces, or maybe I just care about the subnet that's open on the internet, but whatever it is, you can grab these flow logs and it will store it into an S3 bucket, and you can go and analyze it. Just a quick look at what the VPC flow logs look like. And I apologize, I realized that I have some arrows at the end that are a little messed up. So I'm going to fix those. Yeah. So, and then action would be right here. There. Okay. Really terrible arrows. I realize that, but it's with a mouse. Anyways, if you look at this data, it's not full packet capture. It's like NetFlow data. Like it's, hey, there was a communication between two systems. In this little demo, the account here is 12345. It's called basic fake, but there is an interface ID. This is a network, an elastic network interface that belongs to probably an EC2. It could belong to a number of services. Could be an API gateway. It could be, I don't know, just there's a lot of services in Amazon that have ENIs. Right here, I can't really tell what it is, but we'll make an assumption that this is like an EC2. I've got my source and destination IP address, which is also really nice. I got my source port and my destination port. Now, here we got a destination port of 3389. So that might tell me, hey, which service is this trying to hit? But in actuality, I don't really know the service. I just know the port. Since VPC flow logs really don't look at the packet content itself, I can just say, hey, this is probably one, RDP or whatever service based off of the destination ports, but I don't really know unless I've done a good job of ensuring that only certain services are running with standardized ports, which is we're hoping we're doing inside your environments. The number of packets start and stop. This is what you get for VPC flow logs. Now, you do have the ability to say, hey, I want to get full capture from a particular ENI. So you can do port mirroring inside AWS, or you can create your environment so that you have a collection of all this data, and this network traffic going through an EC2, and you do your own collection. But just out as most of the time, what we're going to look at is we're going to look at these flow data. So this flow data can tell me that, hey, someone has attempted to hit port 3389. I can see I have a rejection at the end. So that actually tells me, hey, someone attempted to do something. It failed. That's great. That's fine. I definitely want to say, hey, was there an attempted SSH? Was there a attempted RDP brute force? If there were 100 packets in a minute that were a failed SSH, that might tell me that there is a problem and someone's doing a brute force attack. When you take this data, you can use things like Athena or some other services to analyze this data across multiple services, or across multiple data points to try and look at the whole. An individual packet usually doesn't tell me a lot of information. I got to collect them together with other things. In threat hunting, one thing I like to recommend is that, collecting all your VPC flow logs is fine, but it really becomes interesting if you already are thinking, hey, there's something going on with this particular EC2. Let's say from our previous example, we start seeing AWS S3 LS. So someone has attempted to list the buckets and it was failing on an EC2. That might be interesting. So in that EC2, I may want to say, hey, what's all the network traffic happening right now? Do I see somebody connecting to it from somewhere else? I could turn on VPC Flow Logs for a particular instance and start gathering that data and say, okay, I'm going to start my investigation. I'm going to extract this data in a different, specifically as part of an ongoing investigation. Because Amazon and in cloud services in general allow self-service and they allow elasticity, they allow automation, right? And so I can automatically start creating these flows and analyze this data based off of an investigation. So VPC Flow Logs, there's two places, main places you can send the data. You can send the data to an S3 bucket, which what they'll do is it'll take a whole bunch of packets, not packets, a whole bunch of VPC Flow Logs, collect them together, gzip them, drop them into an S3 bucket. You can build code to go and tear them apart and analyze them, or you can use Athena, which is an Amazon service that does analysis across data sets inside S3. And Athena can extract the data and let you run SQL queries across them. So really nice and handy. You can do it that way. You could also send your stuff to CloudWatch. And so CloudWatch, which I'll talk a little more in a second, but CloudWatch will look at every flow log individually instead of as a group. And each flow log individually, you can start writing filters based off of it. So I can run a filter that says, hey, I see 5 SSH failures in a minute, maybe do an investigation. Not in my organization because I mistype, my password a lot. So, they would catch me just forgetting what my password is on Monday morning. But you have to kind of figure out what your threshold is there. All right. So another one to look at is OWASP, right? We mentioned before that there are a lot of attacks that you'll see through the web services because once we start moving our workloads to a cloud environment, we're probably starting to move things into web-like communications. And if there's an attack against a web server, that's really outside of AWS's sphere of visualization, right? I mean, you can maybe look at network traffic, but not network traffic, but VPC flow logs, but it's just going to be a bunch of port 443 and no, that's it, right? So you have WAFs, you have other services. Amazon's new firewall service too will be able to look at the packets, but you can also go and maybe interested in pulling the data that's on the EC2 itself. In a web server running on an EC2, you could be collecting a whole bunch of logs. So maybe I want to go and grab those logs and do something with it. One way you can do that is with CloudWatch and something called the CloudWatch agent. CloudWatch is a service. I hinted at it before, but CloudWatch allows you to pull logs from lots of different places and in a kind of a centralized environment and start building queries off of them. Or you can bring in the logs and ship them to somewhere else that's actually going to do work on them. Like you could throw them to Elasticsearch, you could send them to your Lambda server, or you could send them to a third-party service. But CloudWatch will look at every one of the logs, and you can start building filters on your logs, whether they're Nginx connection logs or they're, VPC Flow logs. And the example I was looking at the previous page, I'll go back to look, broken access control. Someone is trying to interact with my web server and maybe gain access to the root directory to pull, the password shadow file, right? So they're doing something to manipulate the web application itself. It has a vulnerability. And I might be able to see that in the connection log. So every time that user hits a URL, that URL can be tracked by Nginx can store that into a log. I could ship those logs into my CloudWatch. And then I can take that and start piping it into my AWS environment to do things like Lambda analysis, analyze it with Elasticsearch or whatever that service is. There's going to be a lot of logs collected in CloudWatch. Every one of your Lambda services, your ECS containers, all get thrown into CloudWatch. You can separate these things in cloud and log groups, but there's just going to be a ton of stuff. And that log management is something you have to spend a little bit of time making sure that you kind of think about what's the name of the log group so I can analyze across all my Nginx servers from the marketing team. I might want to put them all together with a common name, but it can get out of hand. So just something to keep mindful of. So CloudWatch is a fantastic service to go and grab that data, analyze that data. And one of the things that Amazon is doing is giving some new service to help with analysis. And one of them is the CloudWatch Log Insights service. So this service takes those logs, and if it can understand the format of the logs, it will quickly allow you to query the information in a query language. It's not at all like SQL, but it has some flavors to it, but it's very specific to these logs. In this particular case on this screen, this is actually a VPC Flow log. CloudWatch Log Insights says, oh, I know what VPC Flow logs look like. I will give you the specific properties, and you can query on those properties. VPC Flow logs, CloudTrail, Lambda logs, and Route 53 logs, all Log Insight understands how to use. If it's another log format, and it's in JSON, it also can auto-detect JSON and kind of understand how to let you query those. It flattens it out, so it can be a little cumbersome if you've got really crazy JSON logs. Most of the logs coming back from JSON aren't too difficult. But you also have a parse command where you can specifically say, hey, I want to analyze these groups of logs. This is how I would parse the logs and how I would query it. So you can create these. You can these logs. You can get some kind of nice dashboarding. If you're going to have a full-time team that's doing a lot of analysis, you're probably starting to ship this stuff to maybe Elasticsearch or maybe to a third-party SIEM or something like that. But this is a great, quick, dirty, I've got some logs, let me analyze it, which is a lot of what we want our threat hunters to be able to do. So there's some other tools out there, which, never have time. We could talk all day about these. What you do there, we have a class, Security 541, which we take this and we expand it over a full day. But besides our CloudTrail and our VPC Flow logs that are being generated by Amazon and our CloudWatch services, which we can go and send our own customized log, you're probably going to be looking at things like AWS config, which AWS config allows you to say, hey, look for this, this is my configured requirement, such as all my S3 buckets have to be encrypted. And it will look and say, okay, all your S3 buckets are encrypted. And if you create an S3 bucket that's not encrypted, it will tell you. AWS config will also do an inventory, and you can set up a snapshot. So every 15 minutes, you get like a giant JSON file of all of your resources and how they're configured. Now it's big, but if you're doing threat hunting and you're like, okay, I got to figure out what my environment looks like, and you put the tools in ahead of time, you could go and query that inventory and get an idea of these are the services, or these are the EC2s that are running at this particular time, and what I need to go look at. I'm thinking in my mind when I say that, but I should articulate it. I'm thinking about that world where you probably have EC2s that are being created and deleted all the time, right? In that elasticity. And so if you're doing, if something happens on a Tuesday, but your threat hunt team isn't able to look at it till Friday, well, that EC2 might be gone, right? you could probably start storing these AWS config data and start looking over long-term to figure out what was all the EC2s on Tuesday and how were they configured. AWS Inspector scans an EC2 system, has some pretty basic ability to analyze things like, are there CVEs? How does the instance match to the CIS benchmark? Some other ones like that. But the inspector can detect problems pretty quickly. And I like things like Inspector because it will actively go out, pull, scan the environment. It can pull, says, hey, there's something weird. It could start off sending something to Lambda to say, you need to go and create an alert inside of the ticket system and start pulling VPC Flow Logs, right? You can start automating the pull of these logs, which is something I really like doing in AWS. GuardDuty and Security Hub and Detective are 3 services that are security-focused managed services by AWS. It pulls together the data that we're looking at here, plus others. And GuardDuty will use, has its own set of rules to do detection of a threat. So it will detect SSH brute force attacks, just like what we talked about in a few slides ago. It will create an alert, and you can go and look at GuardDuty and say, all right, these are the things that Amazon is looking for, and you can detect some things in GuardDuty. Security Hub manages events coming from GuardDuty, but also from Inspector and Config, and it gives you a place to go and say, all right, here's some events. I'm going to go and look at the first one, look at the second one, look at the third one, and kind of work through the process. AWS Detective is a newer service. I think it came out last year. I believe it was last year. And Detective helps with investigation of environment. It allows you to pivot through a lot of different resources that are maybe kind of disconjointed. So if you have an event, you can start off there and start asking questions of the environment to get full information. That brings me to the end of the talk. It's just a quick look at some of the, a couple different threats. And I try to pick ones that are really different from each other. And what are the AWS tools and services that you might want to start looking at to go and extract that log information for your threat hunters. I'll leave you with this. I'm a big proponent of the fact that threat hunting is about looking at logs, but it's also about understanding your architecture and identifying quickly places to improve that architecture. And so I hope in your threat hunting program, you start also creating this, this process to allow the threat hunters to be able to give information back to the architecture team and create the cycle to make that threat hunting better and better. And with that, I think I got 2 minutes, so I'll open up to questions.
Awesome. Thanks a lot, Shaun. Great information. We do have a couple questions, so the timing is perfect here.
All right, good.
Can you talk a little bit about kind of the cost associated with logging and also retention for the logs?
Yeah, so like by default, you can query like CloudTrail logs, and they live for 90 days, but you can specify that you want to keep them longer. And so you're paying for, most of your payment is usually storage. So if you're going to keep these logs around for 10 years, you're going to be racking up some cost. So, but in threat hunting, you're really probably looking at some, well, let me rephrase this. When you're starting to do threat hunting, you need to kind of have an idea that says, we're going to look at logs for the past 30 days, and that's it. You got to have some kind of cutoff saying this is the realm of what we're going to look at. And that data needs to be easily available and searchable and can be analyzed. You might say, hey, look, there might be something that happened a year ago. We probably want those logs, but we probably don't want to make, we want it to be cheaper. So we'll send them to like Glacier or some other kind of service. But I always recommend as an organization, figure out your log retention and then program your environment around that log retention. The AWS CloudTrail, S3, CloudWatch, you can all specify retentions in those, and those retentions will be automated. So you can say keep for a week, and Amazon will handle deleting those files.
Great. Now you talked about CloudWatch. Just from a comparison perspective, we've got a question. Is that comparable to Azure Log Analytics?
Yeah. And so I would say yes and no. From a terms of what logs can be collected and how you would make use of them, there's very much similarities in Azure. Azure does have different services, managed services to help you make sense of those logs. And so Azure has things like Sentinel and other things that are different in what it can detect and also give you a different environment to do that detection. Azure has things like Security Hub, GuardDuty, and Detective that you might use together, but there are 3 different services. So you can get the same kind of data, but it's going to be the way you interact with that data might be a little bit different. But as we're talking, kind of mentioned in other talks, you want to try and automate as much as possible. Both of those services allow you to fully, or both of those environments allow you to automate pulling the data, analyzing the data, doing something with the data if you know what to do, how you want to analyze it beforehand.
All right. Well, awesome. Thanks a lot, Shaun. There's a couple, maybe another 1 or 2 questions here. We're going to transfer over to Slack. But everybody, let's give Shaun a virtual round of applause. Shaun, thank you so much for sharing this information.
All right. Thank you.